Hi, for this question, solve the equation z cubed is equal to 8i, where z belongs to the set of complex numbers, giving you answers in the form of z is equal to r cos of theta plus I sin theta, and in the form of z is equal to a plus bi, where a and b are set of real numbers. Now, what we need to do here is we have z cubed is equal to 8i. First thing I would do, I would find the modulus of this complex number, which is then 8. Okay, and then the argument of the same complex number turns out to be pi upon 2. Right, because this is I and I is over here. So we got 90 degrees, which is pi upon 2. Having found this, now we can say that z to the cube is equal to 8 times the cos of pi upon 2 plus 2k pi. We're going to use this. Alright, plus I sine of pi upon 2 plus 2k pi. Alright, so now z cube, now I want z. Oh, sorry, people just fell down. There's a mess here. Okay. So now what we want is z, which is the cube root of 8, which is 2. And then you've taken the third root, so you're going to have to divide this by 3. So that becomes cos of pi upon 6 plus this one also is divided by 3, 2k pi over 3. Right, so plus I sine of pi upon 6 plus 2k pi upon 3. Now we're good to go, so we're going to take the values of k from 0 to 1 and 2. Right, so when k is equal to 0, what do we have? We've got z1 is equal to 2 into, now this is going to turn into 0 because k is 0, so cos pi upon 6. Alright, and then plus I sine of pi upon 6. So now we want z in the other form as well. So the z1, so cos of pi upon 6 turns out to be a root of 3, and then plus this one is 1 times I is I. So first part, this is our first complex number. Second one is when k is equal to 1 of these, we're going to find the second complex number. Alright, so I've got then cos of, now pi upon 6 plus 2 pi upon 3, because k is 1 here. So pi upon 6 plus 2 pi upon 3 is 5 pi upon 6. Plus I sine of 5 pi upon 6. And if you were to plug this value in your calculator, you should be able to get z2 as minus a root of 3 plus I. Third one is when k is equal to 2, so you're going to take z3 and then 2. Now let us see, you're going to put 2 there, 2 times 2 is for 4 upon 3 plus pi upon 6. 4 upon 3 plus pi upon 6 is 9 pi upon 6. So I got cos of 9 pi upon 6. Okay, plus I sine of 9 pi upon 6. And z3, if you were to plug this in your calculator, you should be able to get 2 minus 2i. Just plug these values and you should be able to see what happens. This one turns out to be 0 anyway. Now for the second part, let's see where. Part B of the question, consider the complex numbers. z1 is equal to 1 plus I, and z2 is equal to the polar form, 2 into cos pi upon 6 plus I pi sine upon 6. We need to write z1 in the form of r cos, so write z1 in the polar form. So what we're going to do, we're going to say that, well, first of all, let's copy the question. So we got z1 as 1 plus I. So if I were to first of all find the modulus of z1, it should be then 1 to the square plus 1 to the square, which is root of 2. And also the argument of Z1 would then be, this is 1. So 1 over 1 is 1, tan inverse of 1 is pi upon 4. So that's the argument. Now, it's very easy for us to write Z1 in the polar form. So I got then a root of 2 into cos of pi upon 4, alright, plus I sine of pi upon 4. So here we are. Part B, second part done. I mean, first part of part B is done. So now move on to the second part. Second part, they want us to calculate Z1 times Z2 and write that in the form of A plus BI, where A and B are set of real numbers. Okay, so we want Z1 times Z2. Now, what is Z1 times Z2? Z1 is basically 1 plus I times Z2, which is, now where is Z2? Okay, Z2, yeah, there we go, in the question. So Z2 is 2 cos of pi upon 6 plus I pi sine z. So, brackets, cos of pi upon 6, alright, plus I sine of pi upon 6. Now, we can only multiply this, okay, if we translate that into something. So 2 cos of pi upon 6, okay, turns out to be root of 3 over 2. So root of 3 over 2. Alright, plus I sine. So plus sine of pi upon 6 is half. So I've got half I, which is then 1 plus I times root of 3 plus I. And this is basic quadratic expansion. So if we were to expand this, Z2 is going to turn out to be a root of 3, okay, plus I plus 3, I mean a root of 3I, okay, plus I square, and we know that I square is equal to negative 1. So basically we're saying, okay, so minus 1 here, so root of 3 minus 1, we've got root of 3 minus 1. And then I is common, so plus 1 plus root of 3. And I've got the I common. So here we are, ZZ2. Now, what do they want from us now? So let's see. Hence, find the value of tan of 5 pi upon 12 in this form. Okay, 5 pi upon 12 for the third part. When they say hence, we're going to use the values. Okay, let's use hence means those results that we found first of all. So Z1 times, if I were to take the modulus of that, it would be R1 times R2. So R1 times R2, then is, so R1 times R2, that is the, what is R1? R1 turns out to be, where is R1? In our complex numbers. So we got for the Z2, okay, hang on, Z2. Z2 is 2, and Z1 is root of 2, yeah. So I got 2 root of 2, alright. And for the argument of Z1 times Z2, I should be able to get alpha 1 plus alpha 2, right. So let's do that. So Z1, Z2, okay, is equal to 2 root of 2 into cos of pi upon 6, okay, plus pi upon 4. This is first angle plus second angle, theta 1 plus theta 2. All right, and then plus I sine of pi upon 6 plus pi upon 4. And basically what I'm saying is that tan of 5 pi upon 12 is then equal to the, this is the complex number we're talking about. So that's the opposite, and that's the adjacent. So I'm going to take a root of 3 plus 1 divided by a root of 3 minus 1. And if I were to do this, I would get, if you just do that in the calculator, you should be able to see that it comes down to 2 plus the root of 3, and here we are for tan of 5 pi by 12. Right, now for the last part of the question, we need to find find the smallest value of p greater than 0 such that the complex number z2 to the power of p is a positive real number. Okay, so we have now for the fourth part, complex number z2 to the power of p, where, alright, p is greater than 0. Okay, and we need to find the value of p. P is a positive real number. And the smallest value of p, well, the smallest value of p would then be, so let's see, 2 to the p, because this is z2, and we know what z2 is all about. Okay, z2 was given the question as this, so this is cos pi pen 6. I'm going to put the p there, plus I sine of p pi pen 6. Sorry. So now, and if p was to be greater than 0, we want to find the smallest value of p that would give p as a real number. We can test some values here, but you should be able to work it out as p is equal to 12. Basically, the angle is just one cycle. It cannot go beyond that. So if I were to put 12 divided by 6 multiplied by pi, I would get 2 pi. So the cos of 2 pi is 1. So basically p should be equal to 12. And sine of 2 pi is 0, isn't it? 0. So there we go. So that's the smallest value of p. Take care.